Today we're going to look at functions and more specifically about functions, the domain and range of function. What is that? Domain and range. Domain is a fancy way of saying all the x values in our problem. Range is a fancy way of saying all the y values in our answer. So uh, I have a series of coordinates. I have 0, comma 4. I have negative 1, 1. And then I have 1, negative 2. My domain is all the x values of that. So I have negative 1, 0, and 1. Negative 1, 0, and 1. Just kind of went in order. My range is all my y values. What's the y half of all of those? Well, negative 2, 1, 4. That's it. Same thing happens if you have a table of values and you need to find the domain and range. Domain, what are the x values? 1, 2, 3. What's the y values or the range of the y's? Here I'm just going to say 4 and 5. I don't need to repeat that 5. I see it twice here. When we do domain, I just want to know what numbers fall in there. I don't care if they repeat, just write it once. Sometimes we have an equation. Those equations we can graph. So if I were to graph that, I get my y-intercept negative 1. I go up 1, over 2, down and back. So I have that line. Now, the difference between this problem and these two are discrete problems. A discrete is just a series of coordinates. The coordinates are not connected. However, I just connected these three because it's an equation and it describes everything on that line. So now I have this line here is a series of coordinates so close together that they form that line. My domain, my x values. What x values does it cover? Well, we've got a line that forever goes in the negative, it forever goes in the positive. We're never going to skip anything going left or right. So we then say something like all real numbers for your domain. My range, my y value, so that's going up and down. Now, this graph is slanted. It's going up a little. So this graph will forever continue to go up because this arrow says it keeps going. It's going to go out and up. This graph says it's going to forever go over and down. So it's going to go up and down. Always. It's never going to stop. With that, we're going to hit every single number ever, and we say all real numbers. Close that off. And for the advanced group here, if we have a quadratic with an exponent of 2, you end up with a graph that looks something like this. That parabola, know that that parabola forever goes downward, but it also forever goes outward very slowly. So from here down always, and then always outward. So domain, let's talk about x's. Very slowly, we're going to move out. We're going to always move out, never skipping any numbers. We say all real numbers. We could even abbreviate that instead of rewriting this whole thing all over. I like to do that. It's like a fancy looking R. My range, here's where things get weird. So all real numbers. My range is not all real numbers because it's not every number always up, every number down. It is every number down, but think of like we're riding an elevator. You can ride this elevator all the way down. You're always going to find a floor that has this line. But ride that elevator up. Floor 1, we hit our graph. Floor 2, we hit our graph. Floor 3, we hit the top of our graph. The second we go over that floor 3, graph doesn't exist anymore. So we write our answer as y and a 3. We hit 3, we say equals, and that 3, our graph exists below, so we say less than 3. Y is less than or equal to 3. It's below 3, but it's also at that 3. That's why that equal sign's there. And that is functions, finding the domain and range.